Okay guys, welcome back. And now that we've got our parametric geometry defined and our major member groups split up into different parameters, such as the bracing and purlins and struts and rafters, we're going to start to generate our space gas model. So in Grasshopper, under the Geometry Gym Structural Analysis tab, if you've installed the Space Gas plugin, you should have a whole bunch of panels here. And these relate to components in Grasshopper which allow you to start to generate a space gas model from the geometry that we've defined. If you haven't got this installed, you can just go to our Geometry Gym, the downloads page of our Geometry Gym website, and install this. It's www.geometrygym.wordpress.com, and if you click on Windows Downloads, Structural Analysis, and then you can download this Space Gas plugin here and install it. But there's plenty of instructions on how to do that online, and if you get in trouble, then feel free to get in contact with us. But anyway, so the first thing I'm going to do is go to the first panel of Space Gas and select a Space Gas bake model component and drag that onto the canvas. This component here is probably the most important component in the plugin, and this is what's going to allow us to bake the model to space gas as we start to build it up. Okay, so the first thing we need to do is assign structural properties to these curves. So as you can see at the moment, for instance, let's start with our rafter polyline curves. They're just curves. So if we go up to the Space Gas Element tab, we can drag a component onto the canvas, Space Gas Create Beam. And what this allows us is to define a structural beam within Space Gas. So this component takes a couple of inputs. The first input is a property, so a section property. The next input is a centerline property, and then you can also start to define some orientation of the structural beam and some other attributes as well. Now, just to get the beams started, I'm going to assign the centerline rafter polylines into these beams. Now, one thing you have to do with a polyline is actually explode that polyline because you can only input a straight curve into this component. So I'm just going to use the explode component, drag that in, and then you'll see that now I've got 12 segments that come out, and I'll drag that into there. Now this component's obviously still yellow because it's failed to get a property. So in order to generate a property, that's under the Space Gas Attributes tab. And if I go under here, I've got a Create Section Property component as well. So I can drag and place that onto the canvas. Something I didn't mention before, when you are using these components, it is good as you're getting started to have the full names of the parameters viewed. And in order to do that, you can go up to the display input here, draw full names. So if I turn that off, I'll get a very simplified input. If I turn it back on, I'll get longer names for these. So the section property input, you can import a profile and a material. You can see that this component is yellow at the moment. If I just click on here, it'll tell me what necessary inputs I need before I can get this component working properly. So the Geometry Gym toolkit has a whole bunch of standard profiles that you can select from, and they're found under the Geometry Gym tab within the Purlin panel. There's up the top right, there's a Geometry Gym catalog profile. So I'm just going to drag that onto the canvas. And if I right click on that catalog profile, there's a whole bunch of country standard profiles that I can choose from. So I'm just going to go with the Australian profiles here, and I'm just going to select a universal beam, say a 410 UB, and that's our profile. I can drag the profile into the profile input, but obviously I still need to specify a material. Now, in Space Gas, there are two ways of defining material at the moment. We can either select a create elastic isotropic material, and this basically allows us to create our own specific material in Space Gas, or we have recently implemented a new way of creating materials, which basically allows you to choose from the standard Space Gas library. So currently, you can only specify this material standard to search via text. We don't have, I guess, drop-down menus of the full Space Gas library. So the quickest way to, I guess, pick your material is to just open a quick model in Space Gas. You can view the properties, have a look at the materials, have a look at your the material library you're wanting. So in this case, AUST, and the material is steel. So I'll just go back. I can create a panel, drag that in, and then I just want to reference steel. And that searches that Space Gas, and you can see the properties of the Space Gas steel have been automatically populated on the output. So that's a steel material which has been created there. So I can drag that material output into the material input of the section property, and now I've created a section property in which I can place into the create beam component. So after I've done that, I now get a display of that beam in the preview, in the Rhino preview, and I can see that my orientation is a little bit wacko here. So what I need to set is basically that orientation vector. Now I can set that just using a unit Z vector, and then you'll see that my my beams are now orientated the correct way. So basically all I need to do now is generate section properties for each of the different elements. So I can basically copy and paste. So what I'm going to do in this instance, I'm going to again merge my my vertical and roof bracing. So I've got all bracing elements at the... Actually, no, what I might do is show you how you can use trees to more effectively have a vertical bracing the vertical bracing and the roof bracing specified in a bit quicker manner. So what I'm going to do, I'm going to want this to be rod bracing. So under the Geometry Gym Purlin component again, I've basically got some components here which allow me to generate a user-defined section, so not a standard geometry section. And you'll see here I can just create a C section with a diameter. So I'm going to create 2 of these profiles, and the vertical bracing I wanting to have a diameter of 16 millimeters, and I might just give that a name of diameter 16 bracing. And for the roof bracing, I will do a 10 diameter bracing. So what I can do here is they're both going to have the same material as the standard steel, so I can do these in one component. So what I'm going to do is a entwine component, which basically allows me to put these profiles on a different branch. Just reorganize this slightly. And then I can entwine these curved components. And I'll just remove that one. I'll delete that. So I can put this into the profile now, and now you can see I've got 2 different section properties. So I've got a section property in branch 1, which is my 16 diameter, and a section property in branch 2, which is my 10 diameter, and I'm just going to simplify that. And I'll simplify this as well. And then I can drag these center lines into this create beam component. So now what that is doing is it's assigning all the center lines in the first branch to the first section property, and all the center lines in the second branch to the second section property. It's a little bit hard to see, but you can kind of see the difference, I guess, between the 10 and the 16 diameter sections in there. Okay, so I'm going to do a similar thing with my purlins. So what I can do is generate another entwine component, and you can copy and paste or do whatever works best for you here. And for these ones, I'm going to want to do little rectangular hollow sections. We might start with a 75 by 50 section. And what I'm going to do is have a slightly thinner wall thickness for my standard purlins, which aren't taking actual load, and a thicker one for the ones that are taking axial load. I can also give a mark to these as well if I want, so I could generate marks on those. But for now, I won't do that. And then just one last entwine component here, and I'll drag my axial purlins into the second one here, which matches the profile. And I'll draw my standard purlins into this one. Now again, these are actually polylines at the moment, so I'm going to need to explode those. Now, this is just the copied explode component, so I can do that in there. And then you'll see that I've gone from 6 polylines to, I'll just simplify that. Now, because I've got a list here, I go from a list. What I'm going to do is actually explode those prior, because you'll see what's coming out of this segment is basically a list of a list. So it's saying each of those polylines has been split into 10 sections, but what I want to do is basically be able to flatten those, so I only have two branches. So I'm just going to make sure that I explode those. Prior to placing them into the entwine component. So I don't need to, I can get rid of that component. Going on with my mouse. But anyway, so now you can see that you've got your purlins. Now, we can see here that they're obviously in the vertical direction, because that's what's specified at the moment. But we might want to orientate these purlins to the slope or curve of those rafter members, which is how they're going to be in reality. So the orientation parameter allows you to either put in an orientation vector, or an even easier way is to basically provide a surface to base that orientation off. So what I'm just going to do, and the easiest way to create a surface is just to loft our original curves into a surface. So I can use the loft component, and I'll just drag those curves in and then flatten those curves. And what that does is we'll create basically one surface along the length of the pavilion. And then I'll just copy that and bring that back over to where we're dealing with our structural. Just show, so I'll zoom in. If I provide the surface into there, you'll see that now the sections are orientated towards that surface, which is good. Okay, so now I'm just going to quickly zip through and apply section properties to the rest of these curve Okay, so now that we've applied all the profiles and section properties to the centerline geometry, we can look at, I guess, doing a quick check to make sure that this comes into space gas okay. So just going back, the last thing I did was to orientate the concrete plinth members based on a vector. They were kind of a little bit skew-if from how I wanted them, so I created a vector based on the backstay base point and the concrete plinth base point itself to allow for that orientation to be as I want it. And I also did a bit of a cleanup with some of the material components and basically just left one space gas material component and wired that into each of the properties that I wanted to be steel. It won't have a big impact on the space gas file, but it just makes it a little bit cleaner. So now I'm just going to go back to the space gas bake model component, and we're going to look at the process to bake this to space gas. So if I just double click on this component, I'll get a save as, and what we're going to do is save this as a .text file, a space gas .text file. I'm just going to overwrite the one I've got there. And you can see in the Rhino command line that it's baked your materials sections and nodes and elements as well. So then I can go into space gas, and it's simply a matter of importing this text file into space gas. So I'll just go, to import from text. I'll select the file, import it successfully, and then there you can see the structure. So I can click on these elements and view some of their properties. So you can see the member sizes come in with some of the section properties, as well as the materials and stuff like that. If I click on the concrete section, you can see I've got my concrete properties, concrete strength as well. So now we're just going to go back to Grasshopper and start to develop this script in a little bit more detail.